Okay, we've already discussed solving these nonlinear equations by substitution. Now I want to do it by the addition method. We learned both of these methods whenever we were looking at linear equations. Now we just need to look at it using nonlinear. And we want to use the addition method if both equations are nonlinear especially, okay? So notice that I have x squared plus y squared equals 9. And a 9x squared plus 4y squared equals 36. Everything is squared. So I definitely want to use the addition method. So what I'm going to do is I'm going to look and say I want to eliminate either my x or my y. Doesn't matter which one I eliminate. Let's eliminate the y values. So that means in order to eliminate the y's, I've got to multiply this first equation by a negative 4. So that'll give me a negative 4x minus 4x squared minus the 4y squared equals a negative 36. I'm going to copy down my second one because all I have to do is multiply that second equation by 1. So that's a 9x squared plus a 4y squared is equal to 36. And I'm going to combine these two. Now notice my y squares cancel out. Oh, my 36's cancel out as well. So that leaves me with a 0. So now then, negative 4x squared plus a 9x squared gives me a 5x squared. I'm going to divide by this 5. So that will leave me that x squared equals 0. Well, normally I take the square root of both sides. What's the square root of 0? It is 0. So I get x is equal to 0. And again, usually I take the plus or minus, but let's think about it. Positive 0 and negative 0, they're the same thing, okay? So I'm going to take this x equals 0 and plug it into either one of these equations. Doesn't matter which original equation I plug it into. I'll be honest, I'm going to go with the one with the smaller numbers. I'm going to do x squared plus y squared equals 9. And in place of that x, I'm going to put a 0. So I get 0 squared plus y squared equals 9. 0 squared is 0 plus a y squared is 9. So I just get y squared is equal to a positive 9. I'm going to take the square root of both sides. Here I do have to pay attention to the positive and negative. So I'm going to get that y is equal to a plus or minus the square root of 9, which is 3. So I actually have y is equal to a positive 3 and y is equal to a negative 3 when x is 0. So my ordered pairs are going to be 0, 3, and 0, negative 3, because I have a plus and a minus. Okay, let's look at one more for addition. Now notice these are not lined up. So I actually have to line up these. I want to get this y squared on the other side. So I'm going to add a y squared to both sides so that it looks like this. Now I have x squared plus y squared equals 16, and I have a 2y squared plus y squared equals 8. I want to eliminate either my x's or my y's. It doesn't matter. I'm going to multiply this top equation by a negative 2. When I do that, that gives me a negative 2x squared minus 2y squared equals a negative 32. My second equation I don't have to multiply anything by. 2x squared plus a 2y squared equals an 8. And I'm going to combine these. Notice what happens when I combine them. The x squareds go away, the y squareds going away, leaving me with a 0. Negative 32 plus 8 gives me a negative 24. All of my variables went away. Does my number equal the same number? No. This one is a no solution, meaning that these two system of equations never intersect. Okay, so try using addition with systems of equations, and then let me know if you have questions.